Thanks for watching this screencast. The objective for this screencast is learners will be able to solve quadratic equations by using the quadratic formula. So I have kind of a general question to ask. If ax squared plus bx plus c equals 0, what does x equal? In other words, without being specific about the values for a, b, and c, can we find a way to generate a formula that always solves the quadratic equation? I want to see if we can maybe use our knowledge about completing the square to do exactly that for this equation. The first thing I want to suggest that maybe we should do is that this is a more convenient process if I don't have a times x squared, if instead I just have x squared. Let me divide the whole equation, every term, by a. That's a legal move. All I'm doing is dividing both whole sides by a, which is a real number, and a is not 0, so I haven't broken any mathematical laws. Let's work with x squared plus b over a x plus c over a equals, 0 divided by a is still 0. We know that completing the square is a process by which I need the x squared and x terms by themselves. So let me take this c over a term and move it to the right side and make it negative. X squared plus b over a times x, I'll leave some room here, equals negative c over a. Now I've got to think about what number completes the square here. So I'm going to sketch out my complete the square box diagram and see if that helps me figure it out. So my x squared I know belongs here, and I know that's going to lead to x times x as the two factors that give me x squared. I need to split my b over a x into two equal pieces since I'm making a square. So what's half of b over a times x? It'd be b over 2a times x. If I add b over 2a times x and another b over 2a times x, I would get 2b over 2a, which is b over a. That works. And that tells me, since something times x equals this, that the number that goes here is b over 2a. And it belongs here as well. We made a square. The sides should have the same length. So what is that number that completes the square? The number that belongs right here and here? Well, it's simply the product of this number and this number. So b over 2a times b over 2a is b squared over 2a times 2a is 4a squared. So we're going to add in b squared over 4 times a squared. But if I add it to the left side, by the addition property of equality, I need to add it to the right side as well. So what that shows me is that I can write the whole left side, which is a very weird looking perfect square trinomial, as this times this. And this is simply this length, x plus b over 2a. And since it's this times that, I can say it's that squared. Now this looks like the square root property of equations could solve this. I think I want to do some work on this side to try and make that as simple as I can first. I'm going to think about taking the square root of that in a minute. It would sure be helpful if I can make one big fraction out of that. The way to make one big fraction out of this is to make sure that both terms have the same denominator. This term has a denominator of 4a squared, but this term only has a. So I'm going to choose to multiply both the numerator and denominator here by whatever it takes to make the denominators here match. The thing that I need to multiply by here is 4 times a, because then the denominator would be 4 times a, or 4a squared, and it would match this one. But I better multiply the numerator by 4a as well. You know, for a fraction, if you multiply the numerator and denominator by the same non-zero number, you haven't really changed what that fraction means. You're writing it in a different form. So here's what I have on the right side now. I've got the numerator here, which is negative 4 times a times c, all over 4a squared, plus the one that I didn't change, b squared, over 4a squared. And on the left side, I've still got my x plus b over 2a squared. I still don't have this as one fraction, but I could easily make it such because they have the same denominator. And when two fractions have the same denominator, you can add them together by adding their numerators. So let's do that. Let's write x plus b over 2a, the whole quantity squared, equals, you know, this is one fraction all over 4a squared. Just because I kind of like not having a negative term first, I'm going to write this term first, b squared minus 4ac. And what I have now is I've got something squared equals some number. And I can use the square root property to solve that. So if x plus b over 2a, the whole quantity squared, equals this thing, then x plus b over 2a equals the square root of this or the opposite of the square root of this. And I'm going to write this way. I'm going to write it in one expression. The positive version of this square root or the negative version of this square root. Now, the square root of a fraction is the same as the square root of the numerator over the square root of the denominator. And one nice thing that I see is that the denominator here has a nice perfect square as its square root. What could you square to get 4a squared? 2a. So let's write x plus b over 2a equals, I'll keep the plus or minus with the radical that will stay in the numerator. Plus or minus the square root of b squared minus 4ac. And we'll put that all over the square root of 4a squared, which is 2a. And all I need to do to get x by itself now is to subtract both sides by b over 2a. And the convenient thing about that is that this term already has 2a as the denominator. So I could just think about switching this term over to the other side and making the b negative. So how about, and I'll pop it over here, you missed a little bit of video magic a second ago. I shrunk all this work to make room. If I solve this for x, then x equals, we'll make this negative, we'll do negative b. And I'll put the rest of the numerator here, plus or minus. You recognize this? The square root of b squared minus 4 times a times c. All over because they have the same denominator, I can make one big fraction out of it, 2a. There we go, we did it. We wrote a formula that it doesn't matter what a, b, and c are. If I know what a, b, and c are, I can find two different values because of the plus or minus sign here that solve the equation. Panthers, you just saw a derivation of the quadratic formula. If ax squared plus bx plus c equals 0, then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That formula didn't just land on some rock from outer space. The work you saw a few minutes ago is why that formula is true. You can complete the square on the general quadratic formula to use it. We'll run through a couple of quick examples here. I know you've seen this before. I hope this is fairly digestible. We want to solve this quadratic equation by using the quadratic formula, 2x squared minus 7x plus 3. It might help to list out what a, b, and c are. A is 2, b is negative 7, c is 3. I'm going to move kind of quick here. So then the quadratic formula says x is the opposite of b, 7, plus or minus the square root of b squared minus 4 times a times c all over 2 times a, 2 times 2. So then that means I've got 7 plus or minus the square root of this is 49. 4 times 2 times 3 is 24. And 4 times 4 is 4. So 49 minus 24 is the square root of 25, which is 4. And the square root of 25 is 5. So you got 7 plus or minus 5 all over 4. Now when we use the square root property to solve equations earlier, we were writing the two separate statements without this combined plus or minus sign. Here it probably makes sense to separate it out and write your two answers separately. So one answer will be 7 plus 5 all over 4. The other will be 7 minus 5 all over 4. In this case, that's 12 over 4, or 3. 7 minus 5 is 2. 2 over 4 is a half. Okay, it's your turn to try one. Before you pause and try it, let's talk about what you should do first. To use the quadratic formula, you really need the thing in standard form, so I'm going to strongly suggest you take this negative 6x and make it a positive 6x on the other side. Pause the video and give it a shot. If you moved this negative 6x to the left side and made the right side 0, then a is 1, b is positive 6, and c is 13. So the quadratic formula says x equals the opposite of b, negative 6, plus or minus the square root of b squared minus 4 times a times c all over whatever 2 times a is. So we've got negative 6 plus or minus the square root of 6 squared, which is 36. 4 times 1 times 13 is 52, okay? All over 2. You know, this is the point in Algebra 1 where you would have stopped because you're going to get a negative under the radical. But we've solved that problem, haven't we? Negative 6 plus or minus, that's the square root of negative 16 all over 2. What is the square root of negative 16? Yeah, it's 4i. So your two answers are going to be negative 6 plus 4i all over 2 and negative 6 minus 4i all over 2. Let's split them up. Negative 6 plus 4i all over 2 and negative 6 minus 4i all over 2. The difference here is that you can't combine these, right? They're not like terms. This is a whole complex number divided by 2. But to divide this complex number by 2, you just need to divide the coefficients. How about negative 3 plus 2i as one answer? How about negative 3 minus 2i as the other? And you've got it. Thanks for watching.